Tashitalek to all the class 12 students, and today I'm going to take the next topic in the chapter applications of derivative. Okay. And today we are going to see how we can apply derivative in finding the equation of tangent and normal to a curve. So this is the next field where we are going to apply derivative. Okay, so we shall see how we can find the equation of tangent and normal to a curve at certain point, right? Now when I say equation of tangent and normal, then here we need to apply some of the concepts which you had learned in the chapter straight line in class 11. Okay, so from that I want to quickly recall some of the small concepts which we need to apply in this topic here in class 12, right? Okay, so first thing, you had seen different ways to find the equation of line of a straight line with different provided conditions. Okay, for example, say you know how to apply the how to find the equation of a straight line when the line is passing through two coordinates. So then with using that condition you can find the equation of the line. Similarly, if you are given a coordinate on the line and if you know the slope of the line, then also you know how to find the equation of line. Okay, so with different conditions you are able to find the equation of line. Okay, so the basic thing in that topic was in class 11. Okay, so that is equation of a straight line. So this you had already studied in class 11. Okay, so we need to use this concept here, so that's why I'm recalling this. Equation of a straight line passing through a point P whose coordinate is say x naught, y naught. Okay, and whose slope is m. Okay, now you know what do we mean by slope. So slope is the steepness of the line. Okay, so now for this we have the, if you have a line, okay, you want to find the equation of this line and it is passing through a point P whose coordinate is x naught, y naught, and you know the slope of this line is m. Okay, so with given these two conditions, that a coordinate on the line and a slope of the line, so using these two conditions the equation of the line is y minus y naught is equals to m into x minus x naught. So this is the equation of the line, if you remember, right? Okay, so y minus y naught is equals to m into x minus x naught. Okay, so this is one thing we need to apply many a times in this topic here. Okay, and the next thing I want to recall is a relationship between the slope of two lines. Okay, two lines, if I say L1 and L2. Okay, L1 and L2. Okay, now if you have two lines L1 and L2 and say slope of L1 is M1 and slope of L2 is M2. Okay, then when the two lines are parallel, that is if L1 is parallel to L2, when the two lines are parallel, then the relationship between their slopes, okay, is the slopes are equal. Okay, when the two lines are parallel. Now you know this, right? Similarly, when the two lines are perpendicular line, if L1 and L2 they are perpendicular, then the relationship between their slope is, the product of the slope is -1, or you may have stated like the two slopes are negative reciprocal of each other. So either you can write this or you can write this. The product of the two slopes when the two lines are perpendicular, then it is -1. Or you can state in the way the two slopes, the slopes of the perpendicular lines are negative reciprocal of each other. Okay, so you can say slope of L1 is M1 and slope of L2 is M2. Okay, so now we need to apply these two things here in the this topic. Okay, finding the equation of tangent and normal. Okay, so first you just need to recall all these things which you had studied in class 11 in the chapter straight line. Okay, so that is equation of a straight line passing through a point P whose coordinate is x0, y0 and whose slope is m. So the equation is given as y minus y0 into m is equals to m into x minus x0. And the relationship between the slope of the two lines L1 and L2, when the two lines are parallel, then their slopes are equal, and when the two lines are perpendicular, then the product of the two slope is -1, or you can say the two slopes, they are negative reciprocal of each other. Okay, so these are some of the things we need to recall. Now let's come to this topic. Now when I say tangent and normal, I mean to say we are asked to here find out the equations of the tangent and normal. Okay, so tangent is generally a straight line. Let me take a curve y is equals to f of x, right? Now on this curve y is equals to fx, so y is a function in terms of x. Okay, so whenever you have any function in terms of x, so every such function will represent certain curve. Okay, so let y is equals to fx be this curve. Now you can see if I take this curve within the interval a to b, right? Now here at each point, whatever point you take, at that point you will get a unique tangent to this curve. Now you know what do we mean by tangent. Okay, so tangent means a straight line which passes through a unique point on the curve. Okay, and it will not intersect the curve at 2 points, right? So that is called as chord. Okay, so when you have this, like, so this is one of the tangents. Similarly at this point, then you will have another tangent. At this point you will have another tangent. So on the curve there are infinitely many tangents you can have. So here we will be asked to find out the equation of a unique tangent. Okay, so you will be asked to find out the equation of the tangent at this particular point x0. So then you have to find out the equation of this particular tangent, right? So when you have infinitely many tangents on a curve, okay, so how can you differentiate these curves? So the curves can be differentiated from the point through which it is passing and the slope of the tangent, right? So that here we get the slope of the tangent. Now how we are going to apply derivative in this concept is, we have this. Now you have to remember when you were first introduced to the derivative using the first principle method. Okay, so the first principle method, when you had derived the derivative using first principle method, at that time we had seen the slope of the tangent is equals to the derivative of y at x. Okay, so therefore you can say, now you note this, slope of the tangent. Okay, now tangent, when I say tangent, it is passing through a unique point to the curve, but actually tangent is a straight line, right? So we are going to use that concept here. So the slope of the tangent is equals to the derivative. So this is how we are going to apply derivative. So to find the equation of the straight line, or to find the equation of the tangent, we need the slope of the line. So to get the slope of the line, we are going to apply derivative. So this is how we are going to apply derivative in finding the equation of tangent and normal. Okay, so now this concept you had studied in class 11 while deriving the first principle method for finding the derivative of a function y in terms of x, dy by dx. Okay, so this is one thing you have to remember. So when you are finding the equation of the tangent, even though it is stated as find the equation of tangent, but you have to remember that you are asked to find the equation of a straight line, right? So whenever you are asked to find the equation of a straight line, you need the slope of that line or the slope of the tangent. So there we are going to apply derivative. Okay, so you will find dy by dx, which gives us the slope of the line. So then we can easily find the equation of the tangent and normal. Okay, this is one thing. Now this is tangent. Now what do we mean by normal? Normal and tangent, they are perpendicular to each other. Okay, so when I consider this tangent, so this tangent is passing through this point x naught. So if you are asked to find out the equation of the tangent and normal at the point x naught, then it means you have to find the equation of this tangent and you have to find the equation of the normal. Now normal means it is passing through the same point, but it is perpendicular to the tangent, right? So the relationship between the tangent and normal are they are perpendicular. Normal means perpendicular. Okay, so here if you get the slope of the tangent, then using the relationship between the slope of the two lines where the two lines are perpendicular, using that concept which I had written in the previous section. So with using that, you can have the slope of the normal, right? And then you can have the equation of the normal. So these are some basic concepts which we are going to use in this topic. Okay, so there is nothing new in this. All the concepts are same as finding the equation of straight line which you had studied in class 11. Okay, the only new thing here is you have to find the slope of that line using the derivative. So the slope of the tangent or the slope of the line is directly given us by the derivative. So this is only a new thing which you are going to learn here. Otherwise, finding the equation of tangent and normal, that can be generalized to finding the equation of straight line, which you had already studied in class 11. So that is all similar to that part. Okay, so the only new thing here is the slope of that line we have to find out, which you can use derivative in getting it, right? So now for this topic we are going to I will take few examples. Okay, so few different types of questions I will take which can be asked under this topic. Okay, now we shall take these two examples first. Okay, so this is the very basic questions which can be asked from this topic, which can be of 1 mark. Okay, so find the slope of the tangent and normal to the curve y is equals to x cube minus x at x is equals to 2, right? So now I always used to say that whenever you have such questions, so first of all you try to understand it using a rough diagram. Okay, so if you are depict this question in a rough diagram, then it means you are clear with the question, you understand thoroughly the question, so then it is very easy for us to solve it, right? Okay, so it is somewhat like this. Now you don't have to draw the exact graph. Okay, so you just draw a rough diagram. So you don't have to write this in your fair notebook. Just for your understanding, you do it on the rough part. Okay, so say you have a curve, this y is equals to x cube minus x, say this function. Okay, this is the graph of this function, right? Now the question is, now on this curve, okay, you will have infinitely many tangents, right? Because there are infinitely many points on this curve. Okay, so from each point you will have a tangent, right? So there will be infinitely many tangents to this curve, but you are asked to find the slope of the tangent and normal, okay, to the curve at x is equals to 2. So if my x is equals to 2 is here, then at this point you get a unique tangent. This is the tangent and this is the normal, right? So you are asked to find out the slope of this tangent and this normal. Is that clear? So this is what the question is. On this curve y is equals to x cube minus x, there are infinitely many tangents, right? Because there are infinitely many points on this curve, and from each point you will have a unique tangent. But you are asked to find out the slope of that particular tangent and normal which passes through x is equals to 2, right? So when I take x is equals to 2, so you get corresponding to 2, you get this point. So at this point you get a tangent and a normal. So you are asked to find out the slope of this tangent and this normal. So this is the question. So first, especially in this topic, you try to depict the question in a rough diagram, and then if you are able to do that, then it means you understood that question. So it's very easy for us to solve it, right? So now we know that slope of the tangent is equals to the derivative of that function, right? So therefore first you need to find out the derivative. So therefore you have y is equals to x cube minus x. This is the curve. So differentiate it to get the slope of this. So you find out dy by dx. So that is equals to 3x square minus 1, right? Now when I say dy by dx is equals to 3x square minus 1, then this is the general slope of all the tangents to this curve. Okay, now you at this point you will get a tangent. Okay, I'll use another colored pen. Okay, so at this point you will get a tangent, at this point you will get a tangent, at this point you will get a tangent, right? So there are infinitely many tangents. So dy by dx is the general slope of all the tangents. So this gives us the slope of all the tangents. But if you want to find out the slope of a tangent, particular tangent, then what you need to do is, in this you have to substitute that particular point at which you get the tangent and of which you want to find out the slope. So if you, here we are interested in finding out the slope of only this tangent. Okay, so then in the general slope, okay, so you put dy by dx at x is equals to 2. You'd need to do like this. So then we get 3 into 2 squared, that is 4 minus 1, so which is equals to 11. So 11 is the slope of this particular tangent, right? So first you understand this. When I get dy by dx, so this is the general slope of all the tangents to this curve. So on this curve you will get infinitely many tangents. So the slope of all these tangents are generalized by dy by dx. Okay, and if you want to find out the slope of a particular tangent, then in this derivative you need to put that value and it gives us the slope of that particular tangent. So this is the thing you have to understand, right? So dy by dx is equals to 11, which means it is the slope of the tangent. Now you know what is the relationship between the slope of tangent and the slope of normal. We know that when the two lines are perpendicular, then their slope, the product of the two slope is -1, or you can say that the slope of the two lines are negative reciprocal of each other. Okay, so you can write it like this. So therefore slope of the tangent is equals to 11. Okay, and slope of the normal is equals to -1 upon 11. So if the slope of the tangent is 11, then the slope of the normal is -1 by 11, because they are negative reciprocal of each other. So this is how you can find out the slope of the tangent and normal to a curve. So this is the first type of question may be asked from this topic, tangent and normal, right? Okay, now after this you look at the second example. Okay, find the equation of the tangent and normal to the curve x raised to 2 by 3 plus y raised to 2 by 3 at equals to 2 at 1, 1. Okay, so now first you try to understand this question and try to draw the rough figure for this question. So if I do it, it is somewhat like this. So let this be the curve plus y raised to 2 by 3 is equals to 2, right? Now it's the same concept is same. So on this curve you will have infinitely many tangents, right? So you have to find the equation. That means you are asked to find out the equation of a unique tangent. So you have to find out the equation of the tangent and normal to this curve at point 1, 1, right? So say 1 is here and 1 is here. So at this point you get a tangent, is it? Sorry, not here. So at this point you get a tangent 1, 1, So you are asked to find out, okay, this point is 1, 1. So you are asked to find out the equation of this tangent and normal to this tangent. So you have to find out the equation of this line and this line. This is the question, okay. So to find the equation of the tangent, right? So I recalled earlier that to find the equation of a line passing through a point, you need the slope of the line also, okay. Now we know that the tangent is passing through point 1, 1 as well as the normal is passing through point 1, 1. But to find the equation, we need the slope of these two lines, right? So to find the slope of the line, we are going to apply derivative. So this is how we are going to apply derivative in finding the equation of tangent and normal. So derivative gives us the slope of the tangent and normal, using with which we can find the equation of the tangent and normal. So first of all, we are going to do that. The curve is x raised to 2 by 3 plus y raised to 2 by 3 is equals to 2. Alright. So now differentiate it. So it's a kind of implicit function. So directly, instead of expressing y in terms of x, I'm directly differentiating it. So that is 2 by 3x raised to 2 by 3 minus 1 plus 2 by 3 y raised to 2 by 3 minus 1. Then you have to differentiate this. That is dy by dx is equals to 0. Okay. So this is equals to 2 by 3. Take out 2 by 3 common. So this is x raised to negative 1 by 3 plus y raised to negative 1 by 3 dy by dx is equals to 0, right? So we have 2, or you can write this. So now when I say that this into this is equals to 0, so then this is a non-negative, non-zero term, so this has to be 0. So I have x raised to, okay, now x raised to minus 1 by 3 is same as 1 upon x raised to 1 by 3, right? Plus 1 upon y raised to 1 by 3 dy by dx is equals to 0. Okay, so now I can write this term will be, okay, this into this is equals to 0. So this cannot be 0, so this has to be 0. So therefore I have 1 upon y raised to 1 by 3 dy by dx is equals to negative. When I transpose this on the right hand side, so this will be negative 1 upon x raised to 1 by 3. So when you keep it over there, so then we have dy by dx is equals to negative y upon y raised to 1 by 3 upon x raised to 1 by 3. So I can write dy by dx is equals to negative y upon x raised to 1 by 3. Is that clear? So this is the derivative we got. Okay. Now we have to find out the slope of the tangent and normal at point 1, 1. You remember? So therefore we have at dy by dx at point 1, 1, which means we need to substitute 1, 1 for both this. So that will be negative of 1 upon 1. So that is 1. Okay. 1 raised to 1 by 3. So that is 1. So we have this is equals to negative 1. So we get this. So the slope of the tangent is negative 1, right? So you can do it like this. So till now we are just differentiating the functions. Okay, so I hope you will not have problem in this, since we had completed the chapter derivative. So we have got this now. Slope of the tangent is equals to negative 1, and slope of, now what will be the slope of normal? It is 1, right? So slope of the tangent is negative reciprocal of slope of the tangent. So we get this. So therefore now you can write this. Equation of the tangent. Okay, so now you know this. So you know this, y minus y naught is equals to m into x minus x naught. So this is the equation of a straight line which is passing through point x naught y naught with slope m. Okay, now we know that this tangent is passing through point 1, 1, right, and its slope is negative 1. So I'm just going to substitute it here. So we have y minus y naught is 1, m, this slope is -1, x minus x naught is 1. This is how you have to do it. So now open the brackets and try to simplify. Plus 1. So this implies we have x plus, okay, you can bring this over here. So we have x plus y and x plus y and this -1. So x plus y minus 2 is equals to 0. So this is the equation of the tangent. Now you know that the equation of straight line is always a linear equation in two variables. You know that. So this is how we have, okay. Then the equation of normal, okay. So again the normal, it is passing through this point 1 1 and its slope is 1. So the equation is y minus 1 is equals to, now here slope is 1, x minus 1. So now you simplify it, y minus 1, x minus 1. So this implies x minus 1 is x minus y is equals to 0, right? So minus 1 minus 1. So x minus y is equals to 0. So this is the equation of tangent and this is the equation of normal. Now it's very simple. Now here you see we had applied derivative only to find the slope of tangent, right, corresponding to which, using the concept of straight line, we get the slope of normal, right? And then all these things you had already studied in the chapter straight line. Okay, you know how to find the equation of a line if you have the slope of the line and a point on the line. So I'm just using that concept here only, okay. So this is how we get the slope of the tangent and normal, right? So now in example 1 and 2 we had taken two types of question. Number 1, finding the slope of the tangent and normal, and second we have taken is finding the equation of tangent and normal. So whenever you see any question on find the equation of tangent and normal, then this is how you are going to do it. So first of all you find the derivative, right, and put that point, and you will get the slope of the tangent at that point, and then you can easily find the equation of tangent, right? Also if you are asked to find out the equation of normal, then with the slope of the tangent you can find out the slope of the normal, because you know the relationship between the two lines when they are perpendicular, and corresponding to that you will get the equation of the normal. So this is how this question is to be done when you are asked to find out the equation of tangent and normal. So this is one type of question which may be asked under this topic. Now we shall take the second type of question. Okay, now we are going to take the third type of question on the topic tangents and normal. And you look at this question. Find the point at which, it means find the point means you have to find the point on the curve at which the tangent, so at that point you will have a unique tangent. So the tangent to the curve, this is the equation of the curve, has its slope 2 by 3. Now here the question is, you are already given the slope of the tangent when you draw the tangent at a unique point. So you have to find out what will be that point, right? So this is the question, okay. And if I just show you this using a rough diagram, let this be the curve y is equals to square root of 4x minus 3 minus 1, and let this be the tangent whose slope is 2 by 3, right? Now you have to find out this particular point, what will be the point on the curve from which, when you draw the tangent, the slope of the tangent is 2 by 3. So this is the question. Is that clear? So first of all you need to understand the question. Okay, now you can write let x1 y1 be the required coordinate. So now we want to find out this x0 y, so x1 y1, okay. So first of all you are going to do this, y is equals to 4x minus 3 minus 1. This minus 1 is outside the root. So you find out first dy by dx, because dy by dx gives us the slope of the tangent. So every time you have to find out dy by dx, so that is equals to, it's a square root function, so the derivative of a square root function is 1 upon 2 square root of 4x minus 3. Then you need to differentiate the inside term. So derivative of 4x is 4 and minus 3 is 0. So this derivative is 0. So that's it. So that is 2. So we have 2 upon square root of 4x minus 3. Alright. Now what we have to do is at point dy by dx, at point x1, y1, you have, this is the slope of the tangent at point x1, y1. So this we are given as, this is equals to 2 upon square root of 4x1. Now instead of x you have to put x1. Why? There is no term y in this, so that's same. This is 3, right? We are given that slope of the tangent is equals to 2 by 3. This is given, 2 by 3, right? Now the slope of the tangent is 2 upon square root of 4x1 minus 3. Okay, so slope of the tangent is equals to, now this is the slope of the tangent and this is the slope of the tangent. So you equate these two, right? So we have these two will get cancelled. So we have square root of 4x1 minus 3 is equals to 3. Okay, so squaring both sides, you get this square. So we have 4x1 minus 3 is equals to 9. So we have 4x1 is equals to 12. So x1 is equals to 3. Okay, now we need to find out the value of y1. Okay, so you can put it here. Okay, now this point is on the tangent as well as it is on the curve, right? So therefore you can either put this point on the line and also you can put the point on the curve also. So here we are going to do that. So we have y1 is equals to square root of 4x1 minus 3 minus 1. Okay, so because this point is on the curve also, so therefore this point will satisfy the equation of the curve. So you can change x1 and x and y in terms of x1, y1, because this is one of the point on the curve. So you can substitute this here, it will satisfy this. So I'm doing that. So we have y1 is equals to, now we have the value of x1, so that is 3. Okay, so 4 into 3 minus 3 minus 1. So 4 3s are 12. 12 minus 3 is 9 minus 1. So 3 minus 1, so that is equals to 2. So we have y1 is equals to 2, right? So this is the point 3 2, right? So 3 2 is the, therefore 3 2 is the required coordinate. So you can sum up like this. Is that clear? So which means 3 2. Okay, so this is 2, let it be 3. Now my graph is just incorrect, so just understand this. So at this point, okay, 3 2, when you draw the tangent to this curve, then the slope of this tangent will be equals to 2 by 3. So this is another type of question on the topic tangent and normal, where you will be asked to find out the coordinates on the point coordinates of the point on the curve which is satisfying certain condition. Okay, now we have seen two types of examples. One is finding the equation of tangent and normal, and one is finding the point on the curve which is satisfying certain condition, right? So this is another type of example. So example 3 and 4 are of same type, finding the coordinates of the point, but the question, the given conditions are different. So therefore I'm going to take this example also, example 4. So we are going to see that. So first you read the question. Okay, find the points on the curve x square by 4 plus y square by 25 equals to 1, at which tangents are number 1 parallel to x-axis. Now x square by 4 plus y square by 25 equals to 1 is a curve, right? So at that curve, on this curve, you have to find the point from which when you draw the tangent is parallel to x-axis, number 1, and also you have to find the coordinates of the point on the curve this curve from which when you draw the tangent is parallel to y-axis. So this is your question. Okay, now before solving it using derivative, so first you carefully look at the equation of the tangent, equation of the curve. So do you remember something which you had learned in class 11? What do you remember? This curve, is it familiar to you looking at this equation? In the chapter conic section, now if I recall, in the chapter conic section in class 11, you had studied different types of conic section. You had studied what is parabola, you know the equation of parabola, you know the equation of ellipse, you know the equation of hyperbola, okay, you know the equation of circle, which is special type of ellipse. Okay, so do you remember, this is one of the conic section. If you remember, either it's a hyperbola, parabola or ellipse. What do you remember? If I say this is ellipse, will you agree with this? Ellipse. So when I say ellipse, so this is the equation of ellipse. Okay, so ellipse means in the equation of ellipse, what you will have is x square and y square, coordinate this quadratic polynomial x square y square, and the sign of both x square and y square will be same. So this is how we represent the equation of an ellipse. So if you remember, so if you have a parabola, then the equation of the parabola, one is linear and the other is quadratic. Either x is linear and y is quadratic, or y is quadratic and x is linear. So this is how we differentiate this equation of parabola. Hyperbola, both x and y are in quadratic, x square y square will be there, but they will be of different sign. Okay, so this is how we differentiate between the equation of ellipse, parabola and hyperbola. So you had already studied that. So therefore this equation represents a ellipse. Okay, so when I say ellipse, we have two types of ellipse. One is horizontal ellipse and the other is vertical ellipse. Okay, so now you look at the equation, what type of ellipse it is, which you will compare the denominators of x square and y square, whichever is greater, right? Corresponding to that, you will get the major axis and minor axis of the ellipse. So therefore we have a greater denominator on y square, so therefore it is a vertical ellipse, which means its major axis lies on y axis. Now these are very basic things you had you know. I hope every one of you will easily draw the graph of this ellipse. You can draw that. So if I do this, so this represents a vertical ellipse. It's very clear from the equation, right? Okay, and this the center is at the origin. Okay, so we write it like this: x square upon x square upon b square. Here it's a vertical ellipse, so we have x square upon b square plus y square upon a squared is equals to 1. Always a is greater than b in the equation of ellipse. Okay, so the length of the major axis is 2a, so therefore length of the major axis is 10. Okay, a is 5, so the length of the major axis is 10. So this point will be 0, 5, and this point will be 0, negative 5. Okay, and length of the minor axis is 2b. Okay, b is 2, so therefore 2 to the 4, so length of the minor axis is 4. So here this will be 2, 0, and this will be negative 2, 0, right? So this is the curve, okay, which represents this. This is the graph which represents this curve. All right, now you look at this. Okay, now without theoretically solving it, we'll just try to interpret it using the graph of the curve. Okay, now we are given this. Find the points on the curve. Now you got the curve. Okay, from which when you draw the tangent is parallel to x-axis. Now you look here. If I draw a tangent from this point, this tangent is parallel to x-axis, right? And also from this point, if I draw the tangent, this is tangent parallel to x-axis. Okay, now anyway, can you find out any point from which when you draw the tangent will be parallel to x-axis? I cannot see any other point other than these two. We don't get this. So 0, 5 and 0, negative 5 are only point on this curve from which when you draw the tangent is parallel to x-axis. Graphically we can show this. So now I'll write it here. So we get 0 plus or minus 5, 0 plus 5 and 0 minus 5. From these 2 points, if you draw the tangent will be parallel to x-axis. Okay, and from this point when you draw the tangent, so these two tangents will be parallel to y-axis. So now can you find out any other point on the curve from which when you draw the tangent will be parallel to y-axis? I don't see any other point. So therefore we get this plus or minus 2, 0. From these 2 points, if you draw the tangent will be parallel to y-axis. So this is the solution to this question. If you directly depict the graph of this curve and graphically try to solve it. So these are the answers. Okay, now we will theoretically solve it using derivative and see whether we are getting the same answer or not. Okay, we are going to see this. All right. So we have this x square by 4 plus y square by 25 is equals to 1. So every time we have to find out the slope of the tangent. Okay, so for that we need to find out dy by dx. We have to differentiate it. So therefore first we differentiate this. So that will be 2x by 4 plus 2y by 25 dy by dx is equals to 1, right? So okay, now I'll just keep it as it is. So therefore we have dy by dx, 2y by 25 dy by dx is equals to negative 2x by 4. I will not cancel it. So dy by dx is equals to negative 2x by 4 into, you have to reciprocate this, so that is 25 by 2y, right? So now you can cancel out these two. So we have negative 25x by 4y. So this is dy by dx. Okay, so this is the slope of the tangent. Okay, number one, when the tangent is parallel to x-axis. Okay, so when the tangent is parallel to x-axis, when the two lines are parallel lines, then the slope, what about the slope of these two lines? The slope of these two lines are equal. We know that. Okay, so therefore when the tangent is parallel to x-axis, then the slope of the tangent and slope of x-axis will be equal, and slope of x-axis is 0. We know that, right? So tan 0. Okay, so that is 0. So therefore dy by dx is equals to 0. Slope of the tangent is also equals to 0. So number one, we have dy by dx is equals to 0. Is that clear? We know that slope of x-axis is equals to 0 because angle is 0. So tan 0, the slope of the tangent. So tangent means tan. Okay, so tan 0 is 0. So we get dy by dx is equals to 0. So always remember that slope of x-axis is 0 and slope of y-axis is not defined. You know that. You had studied that in class 11, right? Slope of x-axis is equals to 0 and slope of y-axis is not defined. Tan 90 is not defined. So here we have to equate dy by dx with 0 because the slope of x-axis is 0 and the tangent is being parallel to x-axis. Therefore slope of the tangent is also equals to 0. So we have dy by dx is equals to 0. Now what is dy by dx? We have negative 25x upon 4y is equals to 0. So therefore we have, now whenever we are equating this, P upon Q is equals to 0. You have to remember this, right? So this implies P is equals to 0. Okay, so denominator cannot be 0, right? So if denominator is equals to 0, then this is not defined. It's not a rational number. So therefore this equation to hold true, the denominator has to be 0, right? So whenever you have any fraction where you are equating it with 0, then always remember that the numerator has to be 0. So we have 25x is equals to 0, right? So we have here this x is equals to 0. Okay, now when x is equals to 0, what do we get? You put it over there. So when x is equals to, or you can write negative 25x is equals to 0, or you can cancel this negative, whatever you want to do. So we have x is equals to 0. So therefore now you put it here when x is equals to 0. Okay, what is y? We get, so this implies y square by 25 is equals to 1. X is 0, so 0 by 4 is 0. This term is 0. So y square by 25 is equals to 1. So this implies y squared is equals to 25. So y is equals to plus or minus 5, right? So x is 0, y is this. So therefore the required coordinate is 0 plus or minus 5. So exactly we get the same thing, right? So when the tangent is parallel to x-axis, okay, so only two coordinates point you will get, from which when you draw the tangent will be parallel to x-axis. So 0 plus or minus 5 are the only two coordinates on this curve from which when you draw the tangent is parallel to x-axis. So number one, it is this is how it is to be done, right? Okay, number two, what you are given, the tangent is parallel to y-axis. Okay, so when the tangent is parallel to y-axis, then the slope of the tangent has to be equal to slope of the y-axis. And the slope of the y-axis, we know it is not defined. Slope of y-axis is not defined. So slope of y-axis is not defined, right? So we have negative 25x upon 4y is equals to not defined. So whenever you have any fraction equated with not defined, then it means the only possibility we have is denominator has to be 0. So you remember that, okay? So when you are equating fraction with 0, then the only possibility is numerator is equals to 0. When you are equating a fraction with not defined term, then the only possibility we have is denominator is 0. Okay, so when I say that, then this implies 4y is equals to 0, which means y is equals to 0. So putting it over there, so we get x squared by 4 plus y is 0, so that term will be 0. This is equals to 1, so we have x squared is equals to 4, so x is equals to plus or minus 2, right? So therefore x is plus or minus 2, which means x can be positive 2 as well as x can be negative 2. So from this point, if you draw the tangent will be parallel to y-axis. So we got the same answer as we had geometrically interpret this question. Is that clear? So this is how this question is to be done, right? Okay, now in this topic we had taken two types of question. Generally the question will be asked on from these two topics. Okay, that is, one is finding the equation of tangent and normal, and finding the coordinates of a point on the curve satisfying certain condition. Okay, so you have to be very much clear with these two types of question. Now I told you many times that here in this topic the only thing, the new thing you had been introduced is the slope of the tangent is equals to derivative. So this is the only thing, only new thing you had been introduced to. Otherwise all are same as the concepts which you were using in class 11 in the chapter straight line. Is that clear? Okay, so for the this topic today you will do exercise 6.3. okay, so if possible you will try to solve all the questions, because this is one important topic. Okay, and if not, then at least try to solve 4 questions of finding the equation of tangent and normal, and 4 questions on finding the coordinates of a point on the curve satisfying certain condition, right? So if you are able to do these two types of question, then I'm pretty much sure that you are clear with the concept of this topic, right? Okay, so this is the second last topic of this chapter. Now we are left with one last topic, and which is a very small and easy topic, so that we will take in the next class. So till then, take care and stay safe. Thank you.